Welcome everyone to this discussion on how to migrate SQL Server databases to Azure. Over the course of this talk today, we'd like to show you how easy it is to migrate SQL Server databases to Azure really quickly. My name is Ajith Krishnan. I'm a program manager here with the Azure data team at Microsoft.
Hey, my name is Robles. I am also a program manager in the Azure data team.
Hi, I'm Dave Levi, and you probably guessed it, I'm also a program manager on the Azure data team. So our agenda for today is we're going to talk about the Azure SQL ecosystem, migration planning, migration tools, migrating to Azure SQL, and then optimizing your Azure SQL environment. So let's talk about the Azure SQL ecosystem. So what is Azure SQL? Azure SQL is, as the slide says, a family of SQL Cloud databases. It's actually bigger than that. We've got infrastructure as a service with SQL Server on virtual machines. We've got PaaS with Azure SQL Managed Instance and Azure SQL Database. And then there's another offering that we're not going to discuss today, Azure SQL IoT Edge. As we look at the scale or what this covers, you can see we have everything from the familiarity of an infrastructure as a service offering, running SQL on a VM like you're used to, all the way across to the flexibility of being able to run Azure SQL Database on a serverless where it shuts down when nobody's using it, all the way up to hyperscale, which is 100 terabytes as an upper limit. So what does it mean to run as a service? Well, if we look at the different hosting models, we start with the familiar on-premises all the way on the left, and you see, that's where you're responsible for everything from even the real estate, building out a data center, having power, having cooling, having generators, all that, all the way up to, installing and actually running your applications. If we move over, we see, with infrastructure as a service is up next, we get rid of a lot of the hard work really that goes with the on-prem data centers. The biggest thing you get rid of is having to budget that 3 to 5 years out, because you want to make sure that the server is still going to be in use by the time you're done amortizing it, doing the capital expense on it. With infrastructure as a service, you're removed from the hardware. You're not stuck with a particular piece of hardware for years. Even if you do a reservation, you can exchange that reservation for something else of a bigger or smaller size if your needs change. So right away, you're starting to see the advantages where you can just reboot the machine into a bigger or smaller size. You can add disk without having to worry about the SAN being out of space. And really all you worry about is, what OS do I run? What version of SQL do I run? Are my drivers up to date? You still have to handle patching and HA and DR and that, but if that's a lot of work, you can move over to platform as a service. Now, platform as a service really lets you focus on value-added activities. What can you do to drive more revenue for your business? What can you do to make sure customers have a better experience? So you're focused on data and applications with platform as a service. We take care of backups, patching, HA. You can very quickly add DR, checking a couple of boxes. So really it lets you focus on driving business revenue, like making your business better. So platform as a service is a really great place to be. Now, over on the right here, we also have software as a service, which is technically a business model. Software as a service is great for those applications where you really can't add any business value by running the application. Think of those third-party vendor applications where they say, hey, if you add an index to our database, we're not going to support you. Or if you have any other databases besides ours on this instance of SQL Server, we're not going to support you. There's really not a lot of ways to innovate by just doing backups and patching, just applying the approved patches. So getting that out of your data center, letting the vendor support it, letting them really focus on what they're good at, and you're able to go and focus on other activities that drive value for your business. There's a lot of value in that. So let's keep going here. Let's look at the data platform continuum. Now, when you're architecting systems, it's good to have a starting place. And, I like to say start in the upper right-hand corner here. So we've got the red text, start here, software as a service. If you can do software as a service, you should. The main benefit or the main differentiator is that there's no business value to be added. There's nothing you can do to innovate or do things better than the competition. So let that just be software as a service. So you can focus on those things where you're able to really drive value. That gets us to platform as a service. So platform as a service is really, the minimum amount of work that you need to do. At least hopefully, there's a reason that there's still, infrastructure as a service, but really with platform as a service, it lets you focus on, let's have good data, let's have performant queries, let's make sure everything's accurate. We take care of the backups, the patching, all those things for you. And you can really focus on how do I grow my customer base and how do I grow my revenue. Now, there are situations where you're going to kind of fall down the stairs here, where infrastructure as a service makes sense. Maybe you need to run an older version of SQL. Maybe you need custom drive layouts. Maybe you need a really aggressive mem to core ratio, a really high amount of memory and a small amount of cores. Infrastructure as a service gives you that. It really lets you twist the knobs a lot more than PaaS does. But it does, make it so you have to do more too. You have to set up your own HA. You're responsible for your own backups. So where you get control, you also get responsibility. Next down our list here is we've got virtual machines on-prem. Now, it seems weird that we would talk about on-prem, but on-prem is really not going away. There's a lot of scenarios, think about like healthcare or manufacturing, where having latency could lead to somebody, getting injured or hurt, could lead to financial loss. There's a lot of reasons why you'd still want to have an on-prem footprint. And that's why we're investing so heavily in Azure Arc functionality. We know that that's not going away. So you're going to see a lot of virtual machines on-prem. And if you need to run on-prem, virtual machines is a great place to be. There's also physical on-prem. Now, this used to be big iron machines, like huge machines that were too big to virtualize or too big to run in the cloud. What's interesting is over the last few years, the hardware has grown faster than the workloads. Now, there's still some workloads out there that, they need that big iron, the huge servers, but it's getting less and less. Now, typically what you're seeing for physical machines is like devices, things attached to equipment, like a cash register, medical devices, PLCs, programmable logic controllers attached to machines and factories. So you're starting to see the physical is very small machines where it's very, very low latency. You don't even want the network latency of the network in the plant to interfere with it. But, you still need that control. Okay, so let's keep going here. When we look at the deployment options, you can see this is kind of flipped from what we talked about earlier. And the reason is, think of our last slide where we talked about, start small, do the least amount of work possible. And then as you're able to add business value, then you go up to the next option. So Azure SQL database is your general starting point for like, I just want to run a database to support my application. Well, Azure SQL database. You can go all the way from serverless, which is, it stops running when nobody's using it. So think about like regular SQL with auto close, same kind of idea, except, instead of just the database turning off on your SQL instance, your compute meters stop running. So you're saving money when nobody's using this database. Now that's the small end, but you can go all the way up to hyperscale, which is 100 terabytes. So a single SQL database, 100 terabytes. That's pretty amazing. Now, as you start to look at like, how do I manage all these small databases that I have out there? Like, what do I do to consolidate them and share my SQL Server licenses so I can, drive that discount using the Azure Hybrid benefit? That's where Elastic Pools come in. It really allows you, like the old consolidation servers we used to do on-prem, where we take a server and just load it up with databases to share the licenses and share the compute. Same idea here. That's what Elastic Pools are for. As we move across, you get to the Azure SQL Managed Instance. Now, this is a little bit bigger footprint than the Azure SQL database, but it does give you cross-database joins and SQL agent. So a lot of folks, just for familiarity's sake, like to start with a SQL Managed Instance. It pretty much gives you everything that you're used to with SQL Server, especially if you work in a high security environment where you don't have access to the operating system, you only have access to SQL. The big difference here is that we block commands that would give you access to the OS. So there's no XP command shell, things like that. We do also have the option with instance pools to consolidate multiple small instances, so you can have separate workloads, but share resources and drive value that way. And then finally, SQL Server on Azure Virtual Machines. That's the I want full control. I want to do it myself. I really want to max out my disk layouts, or I really want to max out my mem to core. I want to do something a little bit off the beaten path. Maybe I want to run an older version of SQL, or I want certain drivers installed on my machine. That's all about what SQL Server on Azure Virtual Machines is for.
Thank you, David, for that excellent summary of the Azure SQL ecosystem. With this understanding of the potential targets, let us look at how to plan the migration to Azure. The journey to Azure starts with discovering all the sources that need to be migrated, which can be manual or automated. This is followed by assessing the sources to evaluate the target options, calculate and compare total cost of ownership, and involve the stakeholders to make decisions. The actual migration phase follows, where we select the appropriate migration strategy for the source, get tool recommendations, and apply the strategy. Once the resources are on Azure, we can further optimize by analyzing the costs, applying offers to realize savings that can then be used to do more. We can also leverage the industry-leading security options in Azure to protect and monitor our data. We will now look at some tools that can help with the first three phases. Azure Migrate enables discovery and assessment at scale. Not only does it recommend possible target configurations, but it also includes estimated costs to enable informed decisions. Azure Data Studio, a cross-platform tool, now with the SQL migration extension, can both assess and migrate SQL Server online and offline. In addition, we have PowerShell and CLI options to automate assessment and migration through command line. All of these are powered by the database migration service and the log replay service. Let's now look at some scenarios to understand the cases where each tool is a good fit. Let us start with a company that has a large estate of SQL servers spread across servers running on VMware, Hyper-V, and physical hardware. We must first discover the servers running SQL instances so that we can choose a group of them to assess. Azure Migrate is a great fit here. It offers stack-specific appliances that can be installed on premises to discover servers. The appliance can then be used to connect to the SQL instances so discovered to assess them against the various target Azure SQL services. On the other hand, if we just have one or even a few instances on premises that need to be migrated to Azure, we can leverage Azure Data Studio or Data Migration Assistant. Azure Data Studio can connect to the instance and then using the SQL migration extension, assess against target Azure SQL services. It can also migrate them online or offline. A third scenario is a set of SQL instances already identified, thus removing the need for discovery. However, they are more than would be convenient for a graphical UI-based approach. In this case, we can use the migration automation commands in Azure CLI and PowerShell. These are powered by the same Azure Database Migration Service that also powers Azure Data Studio. With this, we can connect to the sources for both assessment and migration to Azure. We will now look into how to use these migration tools in a little more detail. Let's start with Azure Migrate. Azure Migrate enables discovery and assessment of SQL at scale. That said, it also supports various other scenarios such as web apps, virtual desktops, and server migrations. It supports third-party tools and centralizes tracking, making it the hub for migration to Azure. We start with the creation of an Azure Migrate project, which will act as a container for the metadata used for tracking and orchestrating the various phases. Clicking on Create Project presents a tab where we can provide a name for the project and a region, along with the choice of an Azure subscription and the source group to deploy that into. Note that the region selected here does not limit assessment to other regions. The new project has no tools added, so we start by clicking on the link to add an assessment tool. There are multiple assessment tools, including third-party tools that Azure Migrate supports. For our discussion, we will be adding the Azure Migrate Discovery and Assessment tool. This will enable discovery and assessment across VMware, Hyper-V, and physical machines. Once we add the Azure Migrate Discovery and Assessment tool, we can start by discovering the source estate. Discovery can be achieved in one of two ways, using an appliance or by importing a CSV with the details. To set up an appliance for discovery, we generate a project key, download and install the appropriate appliance, and configure the same using that project key. Alternatively, one can just download the CSV template, fill it up manually, and import the same. An Azure subscription can have multiple Azure Migrate projects. Each project holds one or more appliances registered with it. Appliances are specific to VMware vCenter, Microsoft Hyper-V, and physical servers. Note that the physical server appliance can also be run on other public clouds if needed. When provided with a list of servers with a network path to the same, the appliance can perform discovery and assessment. The VMware and Hyper-V appliances need a network path to connect to the vCenter server and the Hyper-V host respectively to discover and assess VMs running on them. While the projects and appliances remain the same, assessment, in contrast to discovery, is performed by connecting directly to the SQL instances that have been earlier identified by discovery. The credentials provided as part of appliance configuration are tried one by one. A successful access creates a binding so that the identified credentials are used again first for future access. An appliance, therefore, just needs to be a machine on the on-premises network with access to Azure Migrate, the vCenter server or Hyper-V host, and the SQL servers running on all the various servers. Let us now look at a demo. On the appliance machine, we open the Azure Migrate project page. Clicking on Discover, we can now make a choice between performing an automated discovery or importing using CSV. The automated discovery requires the Azure Migrate appliance setup. Choosing the type of environment provides a guide to the appropriate appliance. We will choose VMware. We provide demo appliance as the name of the appliance and click on Generate Key. Once the key has been generated, we download the zip file with the appliance and extract the contents. A README is included with the steps. Running the Azure Migrate installer.ps1 from an elevated PowerShell starts the install process. Once installation completes, the appliance configuration manager launches in a browser window. If not, there will be a shortcut on the desktop to launch it. Since discovery takes time, the appliance configuration we are looking at has already been completed. As part of the prerequisites, we have provided the project key generated from the portal, and the appliance generated a device code which I used to authenticate the appliance to our Azure account. This uses the device code flow that we are already familiar with in PowerShell. We then added credentials to the vCenter server user and mapped them to the vCenter server details. In the next step, we added domain and local account credentials to connect to all the servers and perform software inventory and network analysis. We also added credentials to SQL Server for discovery and assessment. With all the credentials provided, we click on Start Discovery to initiate the process. Since we already ran discovery, we can connect to the portal to see the servers that have been discovered. Back on the portal, we can see the discovered servers. We also see how many servers have SQL installed on them and how many have web servers. Azure Migrate can be used to perform dependency analysis. To do this, we add servers to the dependency analysis by clicking on Add Servers and selecting the servers to be added. I have already added 2 servers that form part of the Parts Unlimited sample. So we can now go and look at the dependency mapping. In the discovered servers list, we can filter the servers that we want to see, and clicking on the view dependencies for the parts web server takes me to a dependency map view that looks like this. You can see the inbound and outbound dependencies for parts web serve, and in particular you can see that there is an outbound dependency to parts SQL server, which is as expected. Let us now create a SQL assessment. We select the servers that will be part of the assessment group, provide a name for the assessment, and a group name, and proceed to create the assessment. To avoid having to wait, let's look at a previously created assessment. Here is an assessment of all SQL servers belonging to the finance department. We can see that the recommended option is optimized by cost. However, our PaaS offerings have far lower administration overheads. So if you want to see recommendations for managed instance, you can open that card to compare. We have some instances that are not ready to be migrated. To understand the blockers, we can click into the assessment and click through into the readiness issues and warnings for each. This particular instance has more databases than can be supported by Azure SQL Managed Instance. Clicking into an instance that has recommendations provides suggestions for both target deployment type, the configuration, and the suggested migration tool. I will now hand off to my colleague Carlos, who will talk us through the Azure Data Studio as a migration tool. Thank you.
Okay, so I'll be talking about migration to Azure SQL. The first scenario that we see here is an offline database migration to Azure SQL VM. You have plenty of options. The first one, it's kind of a manual approach. When you RDP into your Azure SQL VM, then you use tools like Azure Copy or Azure Data Explorer to copy those backup files from your on-premises environment into that Azure SQL VM, and then you complete the restore process. The problem with that is that it requires a certain level of effort to perform some kind of automation to make this work. Then you have another option. You can back up your databases to a URL that means that all your backup files will be automatically stored into an Azure storage account, and then you can restore from URL. But again, you need to invest some time to create some scripts to perform the backup and the restore process. Then we offer this option. This is using Azure Data Studio, and you can complement Azure Data Studio with the Database Migration Server extension. This extension will allow you to set up a DMS instance which will communicate to a self-hosted integration runtime on that machine, on your on-premises machine. So you can reuse all your backup files that already exist, and this process is going to talk to ADF behind the scenes, and it's going to copy all those files into an Azure storage account, and then those backup files are going to be automatically restored into your target. In this case, it's an Azure SQL VM. So now let's take a look at the same scenario, but in this case, it's an online database migration. So once again, we use Azure Data Studio. We complement this tool with the Database Migration Service extension. This is going to set up the IR, or the self-hosted integration runtime. It's going to reuse those backups on your on-premises environment and start the restore process once those files are copied and uploaded to the Azure storage account. The advantage of this is that your backups are going to be continuously restored as you are taking them. Okay, so you decide when is the time to do the cutover, and this happens just with a single click of the button. Then the final restore will complete and your database will be recovered and ready to be used in Azure SQL VM. As always, you have different options. You can opt to use log shipping, replications, or AD replicas. Alright, so now let's take a look at this different scenario. This is an offline database migration to Azure SQL Managed Instance. The first option you have is to use the backup to URL and restore from URL method. As I mentioned before, it requires some level of effort to automate this process, but you can always take advantage of this functionality of SQL Server to take those backup directly into Azure and get them restored into your target managed instance. Second option again is to use Azure Data Studio. You will be leveraging the database migration service extension to set up a DMS instance, and then after you configure your integration runtime and you reuse those backup files that are in an SMB share, ADF is going to take those backups and restore them to your Azure SQL Managed Instance target. Now, the online database migration to Azure SQL Managed Instance changes a little bit because, once again, you will be leveraging the ADS, the DMS extension with ADS. You'll be reusing those backups, but now Azure SQL Managed Instance is going to use the log replay service. So all those backups that are being taken on the source are automatically copied, uploaded, and restored into the Azure SQL Managed Instance using the log replay service. Then when the time comes, you can cut over, and again, it's just a simple click of the button, and then the Azure SQL Managed Instance through the LRS, or log replay service, is going to perform the final restore and recover that database. You have options with SQL MI. You can always use replication or use the log replay service directly. Now, this is a public preview, and this is a different scenario when you want to migrate a database using the offline method, but your target is an Azure SQL DB. So once again, you will be using the option of the Azure Data Studio through the Database Migration Service extension, and the self-hosted integration runtime on the host machine or your on-premises environment that you are using for this migration will communicate from the source to the target. There will be some package that will be deployed to your Azure SQL DB. So basically it extracts the schema and then it moves all the data from the source to the target. This is in public preview right now, and I will show you a demo of this process. Okay, so this is a summary of the migration workflow. As you can see, everything starts from the on-premises environment, where you have a file share, all those backup files are stored. You will be connecting to your source SQL Server to Azure Data Studio, and then using the Azure SQL Migration extension, you will be able to set up DMS, or Azure Database Migration Service, which is going to communicate through ADF behind the scenes using integration runtime, and it's going to copy those files, all your backup files from your file share, into Azure's storage account. And then finally, the same process is going to restore those backups into your Azure SQL MI, can be your target or a different target as SQL, Azure SQL VM. All right, so let's move on and let me show you how this works in practice. As you can see, I am using Azure Data Studio, and I'm already connected to a couple servers. Here's my on-premises server. I have 3 databases. It's basically the AdventureWorks 2019 in the data warehouse version, the light version, and also the OLTP version. And here's my SQL MI. My SQL MI has no databases at this point, so my goal is to perform an online migration to move these databases from my on-premises environment to SQL MI. Now, we are going to jump into Azure Data Studio here in a different window. I have this notebook, and I'm going to be performing some steps here. The first step when I'm going to perform in my on-premises environment is simply a backup of all databases. All right, so let's execute this. And here we go. Backup is being taken. At this point, I think it should be finished. Yes, all backups has been completed. My backups are being stored in this share folder, on-premises SQL backups, and I have one individual backup folder for each one of my databases. All right, cool. So my backups has been taken. Now I'm going to start performing the migration. First thing you have to do is actually install the SQL migration extension. So I'm going to type migration here, and I am going to install the extension. So yeah, all done. All right, so now I go back to my instance. For the migration to function, you need to be connected to your source server. So I'm connected to my on-premises here. I'm going to click on SQL migration. The first is an assessment. So this is the first step. As you can see, I have 3 different databases as mentioned before. I'm going to select all databases, and if you do such thing, ADS is going to provide you with an assessment, basically a check, if you can migrate those databases and which target is supported. As you can see, I have SQL MI and Azure SQL VM as possible targets. In this case, I'm going to choose SQL MI. There is a video published already that you can check and how to get recommendations for certain SKUs and how you can kind of trace your performance and get better results if you want so. In this case, I'm going to skip that. I'm going to open the results of my assessment. As we saw it before, there is no issues at all. So I'm going to click continue. I'm going to select all databases from here. All right, so next step is actually to connect to Azure. So as you can see right here, Azure Data Studio is asking me to connect to my Azure account. So I'm going to do this, and I'm going to pause the video here for a moment so I can connect to my account. All right, so I am connected now. And now next step is to select my subscription. So I have a subscription where I have certain resources created. For example, in this case is the Azure SQL target. So my Azure SQL target is going to be, as I said, managed instance. So I have a managed instance created already. So let me just navigate to my demos right here. And here you go. This is the Azure SQL managed instance that I want to use as target for this migration. I'm going to click on continue. And this is an online migration. Yes. And as you remember in the previous step, I already have my backups on a network share. Here is certain information that is required for the migration. The first step is to provide the source credential. These credentials are to connect to the source. So I already have the password here, and these credentials right here are different. These are in order for IR to connect to the SMB, the network share. So I'm going to use my local admin here, a VM admin credentials. This is a local environment, so I have no domain. And now I'm going to enter the password again. There you go. And now, in this step right here, you have to specify what is the network share for each one of your databases. I do have that information here, so I'm going to simply copy and paste. So I'm going to grab the information here, put it here, then I'm going to modify, oops, LT, there you go. And now this one is LTP, there you go. All right, so I have my network shares in place. Now it is asking me information about my Azure storage account. I already created this as well beforehand, so I'm going to type DMS. Oh, excuse me, DMS is right here. There you go. I have my storage account right here in place, so I click on next. This step right here is to create the Azure Database Migration Service. I have a few resources that I created beforehand for different demos, but I'm going to create a new one for this demo. So let's select my resource group, and I'm going to name this DMS with this name, DMS with this number right here. All right, so I'm going to click on create, and this is going to provision a new instance for me. I'm going to pause the video right here, and I will be back once this is done. All right, so the creation was successfully completed. Now next step is to download and install the integration runtime. I can follow the instructions from this link and do all this process manually, or I can opt to do this using PowerShell. So here's an automated way to install and set up the self-hosted integration runtime. That's exactly what I'm going to do now. So first step is to copy the key. Then I'm going to go back to my notebook right here. They have a PowerShell. So the first parameter is simple, that parameter, the key. So I'm going to execute this. And the next step is going to take care of the installation and configuration for me. And basically is just using the binaries of integration runtime that exists on my machine already, and is passing the key as a parameter. So I'm going to execute this now, and I'm going to wait until this process is completed. All right, so looks like the process is done. My integration runtime was installed, and my DMS service was successfully registered with the self-hosted integration runtime. That means that integration runtime is ready to go. We check here, it says that it's connecting, and this status will change from connecting to connecting anytime. All right, so now let's move forward with the next step. Next step is basically to test our integration runtime with the connectivity between the integration runtime and our DMS service. And it's successful. So DMS is able to connect to a self-integration runtime on my machine. So I will click on done. And now this is going to refresh and show me my integration runtime connect to this DMS service right here. All right, done, all set. Let's click on next. This is a summary of all the things that I selected in the previous screens, databases, name of my resources. And so I'm going to skip this, and I'm going to start my migration. So my migration just started for the data warehouse, the light database, and the OLTP. So this takes a few minutes to initialize the migration while those backup files are copied into Azure storage account, and then those backups are also restored into my Azure SQL managed instance. I'm going to pause the video here while this is in progress, and I'm going to get back once my databases are in restore mode. As you can see, it's created right now. So we have to wait, and we'll see the result in a few minutes. As you can see here on the screen, the status of each one of these individual migrations for these databases has changed from created to in progress. And you can actually check that from the portal. So if we jump to the portal and we select our DMS instance, then we go to monitor, we can see the same. We can see it says in progress now. So that means that the databases that are in my SMB share are already uploaded. So we are going to give it a couple minutes and we will see that status would change from uploaded to restore. All right, so let's refresh again. And now the status has changed to restore. So if I go to ADS again, and I'm going to close this for a moment, I'm going to refresh databases on MySQL MI. I can see the 3 databases on restoring status. So that means that my migration has been successfully initiated. So if I want to continue, for example, I can take a log backup of all my databases and continue the process until I'm ready for the cutover. Alright, so let's take a look at this second demo. This is fairly simple. I have .NET application that is talking to my localhost database or SQL server, and my plan is to migrate this environment to Azure. So I'll start with my backend database, and I'm going to perform this through automation. That means that I will be using PowerShell scripts for that. The first thing I want to show you is my application. It's already started here. It's a simple .NET application. I have a couple tables, categories, and products, and this information tab returns me the name of my backend, the current backend database server. In this case, it's my on-premises SQL. I'm going to jump into PowerShell here, and this tab right here is the one I want to execute. I will explain you what is going on step by step. The first thing is that going to happen is the declaration of my variables. As you can see, I have different variables here, different information about my DMS instance, information about my SQL source, and the information about my target. Then I have a couple of things here. This path right here is the path for the IR. Remember from the previous demo, you can download IR and automate the configuration. And here's the SQL package download path. SQL package is a utility I'll be using to extract the schema from my source database and publish such schema into Azure. Right, so let's go ahead and get started. I'm going to execute this script in debug mode. So starting, there you go. So that's loading my variables, all good. Let's move to the next step, which is connecting to Azure. All right, all set. Now on my invoke main function, I have this step right here to create my Azure Data Migration SQL service using the parameters I configured through my variables in the beginning. So let's go ahead and execute this. And I'm going to pause the recording here while this is happening, and I'll be back. Alright, so it looks like my DMS service was successfully created. As you can see, succeed. Alright, so next step is the IR. So I'm going to execute this, and this might take a while, so I'm going to stop the recording and get back once this is successfully completed. Alright, so IR was successfully registered with DMS, and everything should be working now. So next step is to extract the schema and then publish such schema into Azure. Alright, let's take a look at the steps at high level. Let me go here. Alright, so as I said, there are 2 steps right here. The first one is to extract all the schema, not data, as you can see. Turning this flag to false, and then publish such schema into Azure. So basically that's going to create all objects I have on my source database. Okay, let's execute this. And this might take a few seconds because he needs to download the SQL package and then generated that pack. All right, so it was successfully installed. Let's click on the extraction now. All right, the extraction was completed, and now the publishing. Let's click on next. All right, so my dat pack was successfully completed. I can jump into Azure and look at my database. It was empty before. There was no table. Let me refresh here. Yeah, my two tables are here. So I can go back to PowerShell and perform the actual migration. So here is when DMS is going to move the data from my on-premises environment to Azure. So let's click on next. All right, so my migration was completed successfully. So it says succeed. No, the provision is dead. So right now the migration is in progress. So this might take a couple minutes, but we can monitor our status here using this command. So let me click on here again. Let's click F5 and let's take a look this in real time. Looks like yes, it's still in succeed status and this is still in progress. So I'm going to pause the recording here and came back once this is done. All right, so my migration was successfully completed. So if I jump back to the Azure portal and I see, yes, it says successfully completed indeed. I can check the details of each one of my tables, how many rows was copied, how many rows was read through the process. So that means that my application is ready to go. So I'm going to stop my application here really quick. And I am going to set up my new the database backend host because now it's my Azure SQL database. Remember, I migrated this. So I'm going to start my .NET application again. And after a few seconds, it's up and running. So now let's go back to the application. Let's check the categories. Working fine. Let's take a look at the products. It works fine. And finally, let's check the information. As you can see, the host name has changed. And this is exactly the name of my Azure SQL DB here. Okay, so that's all for this demo. Thank you so much for your attention.
So let's talk about optimizing your Azure SQL environment. Here are the major pillars in optimizing the migration. Number one, start with a good assessment. Assess your workload, find out what you need to change, and get recommendations for how you should deploy. Next up, verify your application. Get it out there, test early, see how it works differently in Azure and what efficiencies you can take care of. Then configure HADR. Now, no matter what option you pick, whether it be PaaS or IaaS, you have to configure your disaster recovery environment. If you do pick PaaS, though, you're off the hook for configuring HA. So that just comes along for what you get. If you're on IaaS, SQL Server on Azure VMs, what you need to do is have a conversation with your business about what their SLAs are. How many VMs do I need to run to satisfy that workload? So it could be that they don't have very high SLAs and just having a VM out there in Azure is good enough. It could be the other end of the spectrum too, where like hardly any downtime is tolerable and you need to have not just 2 VMs, but you actually need 3 so that you always have HA even when one's down for maintenance. DR is going to be roughly the same conversation, although in a lot of ways it's probably more relaxed because you should only have to go to DR in an emergency. That said, it depends on how important the application is to your business. You may want the same exact HA configuration in your DR environment if it's a very important application. Next up is implement best practices. And this is one of those things that you're changing a lot. So you're going from on-prem to Azure. There's a new set of best practices for running in the cloud. And then you're probably jumping to a new version of SQL. So there's a new set of best practices for the new features that are going to be available to you. So you want to make sure you're implementing all those and taking advantage of everything that you have now. Finally, use the power of Azure. And primarily that means to run hotter. We're used to coming from on-prem where, heavily virtualized environments, we always say that we need a few more CPUs than we actually do because we know that the VM administrator is going to overcommit the CPUs. We're going to end up sharing those. So we may only need 8 CPUs, but we want 12, because we know that we just need to take a little extra as part of the give and take. In Azure, your resources are your resources. So as long as you live within your bounding box, you won't see a performance change. What that means is you can run a lot hotter. There's no difference in performance if you're running at 20% or 80%. You will see throttling if you hit 100%, but you really want to take advantage of that full resource that you have at your disposal. So run hotter in Azure. If you do find out you're running too hot, it's not like you have to go request new hardware. You move the slider, you readjust, and everything's good. So take advantage of the fact that it's moving a slider. It's just changing things rather than having to go through a requisition process to get new equipment. Next up, let's talk about Azure Database Migration Guides. These are available at aka.ms/data migration. They're going to give you step-by-step guidance and resources for how to migrate from a number of sources. You can see them all listed out there to SQL Server in Azure. Another great resource is the Azure Migration and Modernization Program. And there's 2 tracks on this. It's available at aka.ms/AzureAMP, and both of those tracks you can get to from there. One is self-guided digital, where we make everything available and you can run through it yourself. We also have guided deployments. This is for larger migrations, but this gets you expert help from partners or fast track for Azure engineers. It also gets you technical training to make sure you have everything you need to go ahead and be able to run once you're up there in Azure. So in summary, make sure to choose the right Azure SQL offering for your application based upon your business needs. Discover your SQL Server instances across your enterprise with Azure Migrate. Assess and get deployment recommendations with all of our tools. Execute online migrations with Azure Data Studio. Here's some additional resources that we've included with the deck. And now it's time for Q&A. I want to say thank you to everyone for joining us.